Dear students, welcome to the part 4 of our lecture series about one of the most important and essential technique known as molecular beam epitaxy. Dear students, since you know that molecular beam epitaxy is the heart of microelectronics industry, it is one of the most common technique for deposition of highly pure, well-textured and oriented single crystalline thin films. So in this lecture, we will discuss some flip side of molecular beam epitaxy, like what are the disadvantages of this highly sophisticated and very important technique. What are the demerits of molecular beam epitaxy? First, important disadvantage of molecular beam epitaxy is that molecular beam epitaxy is highly costly and expensive technique among all available thin film deposition techniques. Dear student, what do you think why molecular beam epitaxy is the most costly deposition techniques than all the available thin film deposition techniques? The main reason is the creation of ultra high vacuum in molecular beam epitaxy cost too much. Since you know that the ultra high vacuum used in molecular beam epitaxy is somewhere around 10 raised to power minus 8 to 10 raised to power minus 10 torr, which is too much, and for the creation of this ultra high vacuum different types of combinations of high vacuum pumps are required, and due to which the cost of molecular beam epitaxy becomes too much among all the other available techniques. So we will discuss in next few slides, and we will compare that how the other techniques are less costly than the molecular beam epitaxy. So the thin film deposited by the other deposition techniques are chemical solution deposition techniques, and with chemical solution technique, just kindly note that we just required solid precursors, and these are usually in the form of nitrates and chlorides, etc., and these are basically mixed up in a solvent, and the solution is basically formed, and that solution is basically transported onto the substrate surface via different types of spraying or different types of spin coating, etc., and after that we can get thin film. So the chemical solution based deposition technique is very less costly as compared to the molecular beam epitaxy. The available chemical solution techniques used in industry is chemical sol gel deposition technique, chemical co-precipitation deposition technique, micro and milli deposition, and dip coating technique, spin coating technique, and so with all those techniques we can basically deposit thin film. And there is also another technique which is known as spray pyrolysis and screen printing. So all these techniques are used in for the deposition of the thin films. Dear student, please note that the film deposited with all those techniques is usually in the range of few micrometers. So the limitation of thickness is controlling the limitation of thickness with this technique is not possible, and we can just usually. So the student film deposited with these techniques, with the chemical solution based deposition technique like sol gel, co-precipitation, micro screen printing, or spray pyrolysis, etc., basically are less costly because they don't need a vacuum environment. However, the film prepared with those techniques is not uniform, and it is not possible to grow epitaxial kind of thin film with well direction and orientation. Another problem with this thin film, the chemical solution based thin film deposition technique, is that usually the film deposited with those techniques required quenching and annealing temperature in order to convert the deposited film into a single phase thin film. So the film after deposited with the chemical solution is transferred into a high temperature furnace, and the film is basically heated around 800 degrees centigrade or even more. It's depend on the phase formation temperature of the material. So due to this, the structure of the material is damaged, and there is also a possibility of contamination to be transported from the substrate of the chemical solution deposited film into the precursor or into the deposited thin film layer. So due to this, although the chemical solution deposition technique is very less expensive, but it is at advanced level, the molecular beam epitaxy is more advantageous than the chemical solution deposition technique. But at general scale, at higher scale, the chemical solution based technique is one of the easiest technique, and it has advantages in terms of cost, and it is used more in public sector, in like in universities or in institute, because of its less cost. This another type of deposition of thin film is basically done by a physical vapor deposition. Available of physical vapor deposition techniques are thermal evaporation. In this thermal evaporation, usually a vacuum is inside the chamber is basically vacuum inside the chamber is created, but this is not ultra high vacuum, and the precursor is basically thermally heated there, or it could be by induction coil, or it could be due to the like the filaments, and the thermally heated precursor is basically operated and transported onto the surface of the substrate. But dear student, please note that there is a possibility of impurities from the substrate due to the higher temperature inside reaction chamber of thermal evaporation, and there is also a possibility of collision inside the reaction chamber. So due to this, we can the film deposited with the thermal evaporation, we don't guarantee that it will be highly pure as compared, and it will be comparable to molecular beam epitaxy, though this technique is advantageous over the molecular beam epitaxy in terms of cost, because vacuum setup used in thermal evaporation is very low, and it's not ultra high like molecular beam epitaxy. Another physical vapor deposition used to deposit thin film is known as electron beam evaporation or and pulse laser deposition. So in electron beam evaporation or pulse laser deposition, the pulse of the laser signals or the electron beam is basically used, and it's target the precursor material, evaporate the precursor and deposit on the surface of the substrate. So this technique also do not require any kind of ultra high vacuum. It is done usually at the smaller vacuum, though vacuum is created inside reaction chamber in those techniques, but it is less than the molecular beam epitaxy, and due to this, there is a possibility of impurity, though this technique is advantageous over the molecular beam epitaxy in terms of cost. But film deposited with this technique is less pure as compared to the film deposited via molecular beam epitaxy. Another physical vapor deposition technique used to deposit the thin film is known as RF and DC sputtering technique. So basically sputtering is a physical removal of the material, and the material is basically precursor material is removed and transported onto the bombarded and transported onto the surface of the substrate. So this physical removal is done usually at the at the higher vacuum, though it's not an ultra high vacuum like molecular epitaxy. So this basically result in the damaging of the substrate surface and also the thin film. So deposited thin film with the RF and DC sputtering is basically the film is not uniform, and there is a possibility of high level of impurity. So RF and DC sputtering though are advantageous in terms of cost of molecular epitaxy, but in terms of quality, these techniques are these techniques have no comparison to the molecular epitaxy. And molecular epitaxy is film deposited in molecular epitaxy is highly pure and well oriented as compared to these techniques. But the advantage of DC or RF sputtering is that these techniques are less costly as compared to the molecular beam epitaxy. So after discussing all the physical vapor deposition techniques, we reach to the point that though these techniques have their limitation, they have advantages over the in terms of expenses. But still, if we want to deposit, we want to prepare, or we want to fabricate highly pure device, it should be, or it must be based on the films deposited on the via molecular beam epitaxy, because this techniques produce a high level of purity of purity, orientation, and direction of thin film. And another aspect is that with this technique there is we can basically prepare a single phase crystalline thin film. So the expenses is a disadvantage of the molecular beam epitaxy, but the uniformity, the texture, the direction, and the purity is advantage of molecular beam epitaxy. So now coming toward the another demerit of molecular beam epitaxy. The another demerit of molecular beam epitaxy is that molecular beam epitaxy is very sophisticated technique. Molecular beam epitaxy is very complicated technique. There are bunch of additional technique which are a bunch of additional instrument which are connected with molecular beam epitaxy in order to make this technique more suitable. Dear student, please note that molecular beam epitaxy has a combination of different other technique inside it. Number one, first, the formation of vacuum inside the molecular beam epitaxy is very complicated. It's required different types of vacuum pump, different types of combination of the vacuum pump, which are basically used in molecular beam epitaxy. Another sophistication with molecular beam epitaxy is that this technique is attached with different types of other techniques like electron beam evaporation, which is used to evaporate the precursor inside the molecular beam epitaxy reaction chamber. It is also connected with effusion cells, and those effusion cells are present somewhere in the molecular beam epitaxy reaction chamber, and inside the effusion cell the dopant are kept, and these dopants are basically evaporated inside the effusion cell. So that effusion cell is also another type of system. Molecular beam epitaxy is also connected with multi pockets, and these pockets are pockets composed of a precursor material. So it's a multi-pocket setup. And apart from these, molecular beam epitaxy also consists of reflection high energy electron diffraction setup, which is basically used to monitor the thickness of the fin. So this is also another kind of devices. So there are many more types of techniques like SEM or TM, are also like different types of complicated setups are also associated with molecular beam epitaxy. So it's depend on the limitation of the available device. So the disadvantage of molecular beam epitaxy is basically the sophistication. This is why this setup is sophisticated, because it is quite difficult for molecular beam epitaxy to achieve the 10 to the power minus 8 to 10 to the power minus 10 torr of the vacuum pressure. This pressure is too much, it's too high. So the setup is basically of all the different types of instrument is done inside the MBE, because if the temperature is basically decreased, as temperature is changed, the pressure is basically decreased or changed, then it's difficult again to create this ultra high vacuum. So due to this, all the setup of the instruments are basically connected inside the molecular beam epitaxy to make this technique more successful and to prepare the ultra high thin film in a better way, and then the film is basically monitored with the additional techniques. So the MBE basically the complication of MBE is due to the vacuum setup. It's also due to the pockets of which are present, pockets of precursor which are present inside the MBE system. It is also complicated due to the effusion cells, which are basically which basically keep the dopant inside them. It is also complicated due to the different types of characterization technique which are basically attached with this sophisticated instrument. So another disadvantage or demerit of molecular beam epitaxy is that molecular beam epitaxy require high vacuum pressure. So the pressure requirement of the molecular beam epitaxy is the demerit of molecular beam. Dear student, please note that I have also discussed at different points that the ultra high vacuum in molecular beam epitaxy is the heart of the molecular beam epitaxy, but it is also a disadvantage of the molecular beam epitaxy. The ultra high vacuum created in molecular beam epitaxy is somewhere around 10 raised to power minus 8 to 10 raised to power minus 10 torr. Student, please note that for silicon based molecular beam epitaxy, the ultra high vacuum is higher, even it's higher, and it's around 10 raised to power minus 10 torr. So this is the key disadvantage of molecular beam epitaxy, that for we require a higher and ultra high vacuum in order to make it successful. Dear student, please note that there are some available pumps which are commonly used in different types of physical and chemical vapor deposition techniques, such as a rotary pump and diffusion pump. But please note that, dear student, that the diffusion pump especially cannot be used in molecular beam epitaxy, because diffusion pump is based on the oil type of vapor phases, and they can basically cause the impurity inside the reaction chamber of the molecular beam epitaxy. So the diffusion pump is not used in molecular beam epitaxy, though the rotary pump or turbomolecular pump, ion sublimation pump, and cryopump are most commonly used in molecular beam epitaxy. Dear student, please note that it is not possible for single pump like turbomolecular pump, cryopump, or ion sublimation pump to create 10 raised to power minus 8 to 10 raised to power minus 10 torr of high vacuum. So these pumps in molecular beam epitaxy are basically used in combination. Okay, so they it's depend on the system, but this high vacuum is basically prepared, or is being produced by the combination of different types of pump like cryo and turbomolecular, etc. But however, the cryo pump is most common in molecular beam epitaxy. It has advantages, dear students. Cryo pump usually use the liquid nitrogen, and its temperature is somewhere around minus 170 degrees centigrade. So that's the very low temperature basically of cryo pump act as a sink, and this sink is for impurity. So the low temperature is a sink for the impurity available in the reaction chamber of molecular beam epitaxy. So it's also play a vital role in order to decrease the impurity inside the molecular beam epitaxy reaction chamber. So due to this, the cryo pump is most common in the molecular beam epitaxy, though it is in combination with the turbomolecular or ion sublimation pump. However, the diffusion pump is not used in molecular beam epitaxy due to the vapor phase of the oil, which can possibly create the impurity in the epitaxial thin film.